Hello, my dear students. This is MathDOC. So during this session, I mainly focus on domain and range of a function. Domain and range of a function. This is a major part of a function. So we know a function means a connection between two variables x and y. Then domain means input values and range means output values. So output values depend with x values. That means input values. Okay. Then domain means possible x values. Domain means possible x values. So let's do few examples. So we know function can be classified, no? Functions can be classified. As according to the relation, functions can be polynomial function, then rational functions, irrational functions, logarithmic functions, exponential functions, trigonometric functions. Likewise, there are many function types. There are many function types. So as according to the relation, its domain can be given. Domain can be given. So you focus, there are three major things. There are three major things on domain selection. So first one, so if we have denominators in a function, so you remember denominator can't get zero values. Denominator can't get zero values. And also, so if you have irrational relations like square roots, then if you have square roots, then within square root values must be positive or zero. That means within square root values must be non-negative. And one another thing, if you have log functions, then within logarithms, value must be positive. Those are the major parts of selecting domain. So let's do few examples. So with the relations, we can identify the function with that given three conditions. Okay, let's see. Okay, now you consider an expression y equal x plus 1, y equal 2x minus 1, y equal x squared plus 2x minus 1, y equal 3x minus 3x squared plus 4x plus 5, y equal x to the power 4, y equal x to the power 10 plus 4x 9 plus x plus 1. So these functions are polynomials, no? These functions are polynomials. Then we don't have any restrictions for polynomial functions. We can put any value for x, any real value for x. Then here domain, we denote by df. Domain means possible x values. Then for each case, you remember domain is the real set. Then no restrictions on the polynomial functions. Now let's move to rational types. Rational means division of two polynomials. If we have rational functions, we need to check whether it contains denominator zeros. So for denominator zeros, the function is undefined. Therefore, for rational functions, we eliminate denominator zeros. Consider y equal 1 over x, y equal 2x minus 1 over x plus 1, y equal x minus 1 over x minus 1, x minus 2, y equal x squared plus 2x minus 1 over x, x minus 1, x plus 5. So here, these functions we call rational functions. Rational functions. Then for rational functions, remember denominator zeros must be eliminated. So here domain usually real numbers, then denominator 0 is 0. You remove it. Likewise, you can remove. Then for this function, domain usually real number set, then you remove denominator 0. Denominator 0 is minus 1. That's how we remove. Here domain, here real here function usually real number set, then there are two denominator zeros. One is 1, the other one is 2. 1 and 2. You remove 1 and 2. That represents set difference. Set difference. So likewise, you can get domains. Then here another function y equal x squared plus 2x minus 1 over x, x minus 1, x plus 5. Then we have denominator 0, 0, 1 and minus 5. Then you need to remove that denominator 0. Okay, let's move further. Then here domain real value without 0, 1 and minus 5. Then you identify for this type of rational functions, their domains are different. But for polynomial functions, domains are real set. Real set. Now let's do another example. I told you three conditions. Remember it again. One thing, denominator zeros must be eliminated. And second thing, square root, within square root value must be non-negative. That means that can be 0, that can be positive. And also one another thing, within logarithms, you need to select only positive values. That is the condition. Those are the conditions of selecting domains. Let's do another example. Consider y equal root x, y equal x minus 1 root, y equal x plus 1 root, y equal 1, 2 minus x. So here these functions are irrational. These functions are irrational. So you remember within square root values must be positive. Then domain means possible x values. Domain means possible x values. Then you need to write possible x values for domain. That's it. Then here within square root values must be positive. Then here domain x real value x such that x greater than or equal 0. Greater than or equal 0. And for this case, domain real value x such that x values here that must be positive, no? Therefore, x values must be greater than or equals 1. Greater than or equals 1. So you better write within curly bracket because domain means a set. Then to represent a set, you need curly brackets. Then consider here domain x element of real set x such that here this value gets 0 at x equal minus 1. Therefore, x greater than or equal minus 1, this is the domain. Then further, for this case domain x element of real set, then within square root value must be positive, no? Then x value must be less than 2. That means 2 minus x must be greater than or equal 0. Then solve this inequality. Then value must be less than or equal to. Value must be less than or equal to. Then here domain x such that x less than or equal to. That is domain for irrational functions. That is domain for irrational functions. So you remember for polynomials, all domains are real set. For rational functions, you need to remove denominator zeros. And for irrational functions, you need to select within square root positive values. Within square root positive values. And further, let's move for logarithmic functions. Consider y equal log 2 base x minus 1. I told you for logarithms, within log value must be positive. That can't get 0 values. That can't get negative values. Therefore, you select this part, then x minus 1 greater than 0, x value greater than 0. Therefore, here domain x real value x such that x greater than 1. Consider y equal log 2 base x plus 2. Then this value must be positive, no? then x plus 2 greater than 0, then x value greater than minus 2, then domain x real value, x such that x greater than minus 2. Here these are logarithmic functions, log functions. So that is the major idea of domain and domain. Then first thing we need to identify what is that function. No? First thing we need to identify what is that function. Then as according to the function, we need to select possible x values. Then that possible x value set we call domain. Possible x value set we call domain. And also here we have another special things. That means a function can be exponential function, and also a function can be logarithmic functions, or function can be trigonometric function. So to identify its domain, you need to identify the characteristic of each function. Okay, and also we can get sum of two functions, that means combination of two functions, that can be irrational function and polynomial function combination, that can be logarithmic functions, polynomial function, or irrational function combination. Then for each case you need to select combine domain. Okay, that means you need to consider about all the properties of each functions when selecting possible x values. Let's do a few examples again. Now you consider y equal 1 over x minus 1 plus root x. Okay, it contains rational type and it contains irrational type. Then when we put inputs, that means when we get inputs, we need to consider about both. Then for this case, rational x not equal to 1, and for this case, irrational x greater than or equal 0. So when you mark on a number line, here x value is greater than or equal 1, this must be selected, and for this case x not equal 1, this must be eliminated. Therefore here the domain x real value, x such that x greater than or equal 0, but x not equal to 1. That is the domain. So that means if you have addition, subtraction, multiplication and division of two or more functions, you need to check each and every functions. You need to check each and every function whether it is satisfied or not. So you remember we have three conditions. One is denominator 0 must be eliminated. The other one is within logarithms positive, and another thing within square root that must be positive or 0. Okay, those are the major conditions when you are finding domain. Then finally you need to identify different type of functions. Then only you can identify how can we select possible x values. But anyhow, you remember domain means possible x value. That means possible inputs. Domain means possible inputs. Then range means possible outputs. When finding range, so that connected with inputs, then as according to inputs, we get outputs. Then the best way to find outputs, you better to sketch its graph. Then as according to graph, we can select possible y values, that is the range. And also, we can do another thing. That means we know how to get inverse function. No? Then likewise, you subject x. So usually a function y is subjected, y is expressed in terms of x. No? Then we can select possible x values, that is domain. So if we subject x value, then x is expressed in terms of y. Then when you subject x, so the expression in terms of y, then you think what are the possible values of y? Then the possible values of y, we say its range. Then with the previous three conditions also you can identify range of y. range of y. Let's analyze it again. Let's analyze again. See this one all? Okay, I'll do few examples for finding range. I'll do few examples for finding range. Clearly see this. Consider this function. Consider this function. Y equal x plus 1. So we know domain real set. Then you subject x, then y value y minus 1. Then the possible y value we say range. We denote by RF. Then no issue for y. Then real set is its range. Here example 1. Then I told you when you are finding range, you subject x. You subject x. Consider second example. Y equal 1 over x minus 1. Then domain possible x values. Then we need to remove 1. Then real value without 1. So when you are finding range, you subject x. Cross multiply x minus 1, 1 over y. Subject x, 1 over y minus 1. Then you check possible y values. Then denominator zeros must be eliminated. Then possible y value mean range. Then we denote by range RF. Then real value, here denominator 0 is 0. Real value without 0. Real value without 0. That's how we select domain and range. So see this one. Y equal x squared. Here domain. Any real value possible, which is polynomial. No? Then you subject x. Then x equal plus or minus y. Square root. Then possible y values means range. Then now we check possible y values. We know for irrational thing, within square root must be positive or 0. Then here range, y real value, y such that y greater than or equal 0. This is its range. Then to represent range, you take y. To represent domain, you take x. Okay. Then when you sketch this function, here x-axis, y-axis, here y equal x squared. We know it is parabolic shaped graph. The graph is now like this. Then all x values are possible. Therefore, domain real set. But positive y values are possible with 0. Then here range positive real value with 0. Then this thing we can further denote it by positive real value is 0. This is its range. Likewise, you can identify domain and range. Let's do one another example. You consider y equal root x, y equal root x. So here domain, possible x values, that means positive real value is 0. This is domain. Now you subject x equal y squared, x equal y squared. Then here you need to select possible y values. But here let's check this graph. Here x-axis, y-axis, x-axis, y-axis. Then as according to that, we can sketch this. Here the graph. Then its range, again positive real value is 0. Positive real value is 0. I told you range mean that range connect with inputs, no? Then range contain input-output relation. Input-output relation. Therefore, here domain positive real values. Then when you subject x, equal y square, you identify y can get any real value. Y can get any real value. But here, remember, all y values are positive here. Therefore, with inputs, you need to select outputs. Not only with the expression. With the expression, we can identify for some certain range, but you need to select with input as well. Okay? Then that is the major property of range and domain. So this is major thing about functions, domain and range. So anyhow, to identify domain and to identify range, you need to mainly focus about different types of functions and their characteristics. That is the thing. So many things we need to discuss further one by one with the function about domain and range. That's it about domain and range. Thank you for watching us.